Okay, we're going to get started now on what I had planned. Sorry, things didn't go right this morning. But I want to draw your attention to some organizational things in the course. Over here, you've already found assignments. I want to talk to you about Friday's assignment. So you will have regular web work, again, due Friday morning, 8:45. And then what we'll do is pretty much every single recitation, you'll have a written quiz. Okay? So the web work is good, but there's an aspect of you being able to write out things that's really important. So we're going to have a written quiz every Friday. But here's the deal. I'm going to post the quiz Wednesday before. Here it is. Right here. That is the quiz. It's not different numbers. It's the quiz. Everyone's going to get 100, right? In theory. Okay. So, and then written homework, I've thought through this. When your recitations are Friday and Monday, and I've thought through this. I think we're going to make written homework due on Wednesdays. Okay, so the first written homework will be due next Wednesday. I think that'll be the best. There's lots of issues, and I decided on next Wednesday. So I have some of that up there, and I'll probably add some before the weekend. Okay, so you can get started on that if you want. And again, it's important that you also, besides doing online homework, that you're writing, okay? Lots of times it's asking for explanations. If you just jot down a few words, a phrase or something, that's not enough. You have to write out complete sentences explaining your reasoning, the type of reasoning that we're using in class, okay? So, and a big portion of the homework will be graded on professionalism, meaning neatness, organization, clarity, completeness, okay? And by completeness, whenever there's asking for explanation, you write it out in full sentences. Okay? There's a slight change on number 30 here, so just change the wording of those questions there for number 30. But the written homework will be posted ahead of time, but we'll do on Wednesdays. So for Friday, you've got a normal web work, and you're getting ready for the quiz and recitation. And then that's the same quiz in Monday's recitation, okay? Exact same quiz for Monday's recitation.
What if we don't have recitation on Monday to do Labor Day?
Oh, that's true. Okay, so I guess for this time, so then for Monday recitation, that's a take-home quiz. You're going to print that out and finish it and turn it in Monday. That's the best we can do, okay? So Friday, you're taking it, but you have it ahead of time. Monday, we'll just hand that in lecture. So print out a copy, fill out your responses, okay? Do it by yourself. Not class Monday. Wednesday, right? Wednesday. Okay, so turn it in Wednesday with Wednesday's homework, okay? It's in the book. See, starting on page. This is the written homework. It's going to tell you page number and numbers. That's referring to the workbook. Okay, so the workbook consists of kind of two different things. Worksheets, like I just assigned, that you do in class and you write in the book. But then when I assign homework questions, that's in a different section at the end of the module. There's no room in the book, and you're handing it in, so you're doing it on your own paper. Okay, does that make sense? So investigations are things you'll do in class and recitation. You'll write in the book. They leave you room. Homework is all together at the end of the module. There's no room to write. You're writing on your own paper to turn in class, in lecture. Okay, other questions? Yes, ma'am?
It says maybe more like...
Yeah, I'll add it by the weekend, or this weekend, or something like that. Yeah, but it's due Wednesday. It depends on how far we get, on Friday. Other questions?
So for us who have recitation on Friday, are we doing the quiz?
Yes.
Friday?
Friday, so you're going to do it like normal, like we'll do it all semester. You have the quiz ahead of time, but okay. And so the other thing is, don't bring a printout. He's going to have a full stack of clean quizzes. So do not bring a printout of the quiz to recitation. You have it to get ready, but he'll provide you the copy that you're going to write on. Okay, these are all good questions. Other questions? No, that's not a question. Okay, so is this more distracting than helpful? Can you see if you can find which switch will turn that one off? I don't have lights down here. Do I? Wait. Wait, I do. Hold on. No, that's not lighting. No, I don't have a lighting. Some of them have lighting down there. I don't. See if we can just get the one that will turn that off. Okay. So, that's brightness. All right, he'll work on it. Okay, we'll just do our best. All right, so getting ready for Labor Day barbecue. You need to buy chicken, right? So you're going to have your friends over. You're going to barbecue chicken. Chicken costs $3 a pound. So I want you to start by, I want you to define two relevant variables here. And so we're thinking through, what are my criteria for a well-defined variable? So I want you to define two variables relative to the situation. The two most obvious, okay? So there's kind of two obvious ones. No, turn that off. Make sure that's off. Whatever you just turned on. These lights in front of the screen. Yeah, you just turn the board lights on. Can you turn all the board lights off? Okay. Okay, so what would be, so if I wanted to say X was something, there we go, thank you, that's good. And, I'll stop for a second. All right, so X, so we're gonna call the first value X. Don't touch anything. Can everyone see your paper?
Yes.
Cool, all right. X, I want to name a variable X. What might X be? X, yes sir.
Pounds of chicken.
What's that?
Pounds of chicken.
Pounds of chicken. Pounds of chicken. Okay. We do it's just about. Was you gonna say something else? Yeah.
I was going to say the amount of chicken each person will eat.
Okay, you could do that. So amount of chicken each person will eat in pounds. Relative to the situation, though, we're still buying it, right? We're still buying it. So if we kind of put those two together, maybe you had something like this. Oh boy. How about this? Total weight of chicken to be purchased in pounds. Now, if it wasn't exactly that, that's fine. But weight, you can add, so weight of chicken or number of pounds of chicken is the key. Weight of chicken in pounds or number of pounds of chicken would be good. Okay? I need a y variable. Who can define a y variable? Yes, ma'am.
The amount of people.
No, relative to this. Relative to what the information I'm giving you. So total weight of chicken is going to be related to what? Yes, sir. Okay, so we want to define a good variable. So y equals, so a good variable. Cost of the chicken in dollars. Cost of the chicken in dollars. We need a unit when we define a variable, right? Okay, so let's start easy here. Small get together, 1 pound of chicken. How much? What's the value of y when the value of x is 1? Okay, and then the value, so, oops, didn't want that, I want this. I'm going to buy 3 pounds of chicken. That's x equals 3. Now when x equals 3, y equals 9. 7 pounds of chicken would cost? 12 pounds of chicken would cost? And notice what happened here. When I put those corresponding values of X, number of pounds of chicken, and the corresponding value for Y, cost in dollars, what did I get? So let's look at like right here. What's going on right here? What is this? This point came up on this graph. So this axis here is, it's the meaning of that axis right there. Total weight of chicken. That's our X quantity. And then this one is our cost, or Y quantity. So this point popped up. What is the meaning of this point? What does it mean? Okay, I heard someone say 7 pounds of chicken will cost $21, right? So that point actually is 2 pieces of information, right? 2 corresponding pieces of information. When the cost is 7, when the number of pounds is 7, the cost is 21. So a point on this XY plane represents the values of 2 quantities corresponding together, right? So you get 2 pieces of information from that point. So we have these other points too. X equals 1, Y equals 3, 3 comma 9, 12 comma 36. Okay, are those the only possibilities? No. So let's look at some more possibilities here. So, every one of those points represents what? Tell your person next to you. Every one of those points represents, or let me just pick one here. I want to pick one. This one right here. Explain fully to the person next to you. What does that point right there represent? Somebody do, tell me. Yes, sir?
2 pounds of chicken is $6.
2 pounds of chicken is $6. That's what that point says. That 2 pounds of chicken is $6. Just got here right. All right, do I have all the possibilities now? No. And just like all Americans, what? We want more, right? Just one. Just one. Just one. Sorry. Wow. Come on, just one. There we go. Okay. So this is obviously forming a line. But what my point is that when you see a graph, in this case it's a line, what is it really? What are you really looking at? No, rate of change. I never said anything about rate of change or function. Yeah. No. No. I didn't say any of those things. What I'm getting at something here, based on our previous conversation. When you're looking at the line, what are you looking at? Points. You're looking at points. You're looking at points. Okay? Because I can come along here, I can take all these off and make it look more like what you're used to. Okay, so here's just a few points. This is what you're used to seeing. Like what you would draw with your pencil, right? You would just start here and you go zoom like this. You'd sweep the pencil across the page. So when you're looking at this, so right now, the way I'm showing that graph, how many points are you looking at? How many points are you looking at? 5? Infinite number of points. That's what you're looking at when you look at a graph. You're looking at points. It's just easier to do it that way, right? So it take, if we drew all the points, it would take all class and longer, right, to draw every single point. But in half a second, we can draw a line. So when you draw a line or when you see a line, what you should be thinking is, that's a bunch of points. That's what that is. Now, what are these blue things? Well, I've just highlighted 5 of them. That's all this is. I'm just highlighting 5 of the infinite number of points that this line represents. Okay? So it's not a stick. It's not a wire. It's a collection of points, and each point has a meaning, right? We talked about that. Each point, like this point here, means that 3 pounds of chicken will cost $9. And there's an infinite number of pieces of information like that. Okay, so now we want to look at, we've been talking about changes. Okay, so as x changes from, let's look at 1 to 3. So now we're talking about, so it's like, for instance, we have a pound of chicken on the scale, and we say, oh, that's not going to be enough for my party. So then what do? Say, call the butcher, and we say, how much? We're going to add how much? 2, right? So we have 1. We get an additional amount of 2, and so that the pounds on the scale goes from 1 to 3. Okay? What does y change from? So figure it out. From what to what? And so now we can define a little smaller. Now I can define delta x as a new quantity, right? So x is the total weight. Delta x, we talked about last time, and you did some practice, change in weight of the chicken. And then delta y, it's a new quantity based on y, the change in the cost. All right? So you told me that when x changes from 1 to 3, y changes from 3 to 9. And therefore, the change in x is 2. The additional pounds is 2. And so the change in y would represent the additional cost, which would be 6. 2 more pounds, going to cost $6 more. Okay, how can we show that first line in that new table over there? How can we show that on the graph? How can we show that on the graph? Where are we starting from?
0.
Are we starting from 0? 1. X equals 1, right? Okay. Starting from x equals 1. And what happens first? So here we are, 1 pound of chicken on the scale. What happens first? Add chicken. And how much chicken did I add? 2 pounds to get up to 3. How can I show that on the graph? Here I am at 1, 3. Right. What kind of line? Horizontal, right? And that horizontal line represents what quantity? Not a number. What quantity does it represent? Delta x. And in this case, delta x equals 2. But when that happened, when we added 2 more pounds, what also happened? Cost went up. How much? And I can show that. Equals. Okay, so I want you to, in your notes, you're making this too, I want you to finish the table and the graph. For these changes, x changes from 1 to 7, 7 to 12. Oh, don't do that one yet, just those next two. So 1 to 7 and 7 to 12. Finish the table in your notes. Finish the graph in your notes. Check with the person next to you. Compare what you got. Okay, where's Jacob Connell? Jacob Connell. I will know you by the end, so you can't hide anymore. How about Alexis McKay? Alexis, tell me about from 1 to 7. Y changes from? From 3 to 21. Good. Change in X? 6. Change in Y? 18. And how am I going to represent this on the graph? Tell me how what I should draw. Okay, so I'm going to do red here. Whoa. Try that horizontal line again. Okay, and you want me to label that as? Change in X of 6, okay. Horizontal? Yes, so starting there. So when we increase the number of pounds by 6, what happens to the cost? Delta Y is? Okay, good. Last one. Where is? Marcus Frazier. How about Walden? Where's Walden? Tell me. Next line.
Okay, so we're at 7 to 12.
Yeah.
Okay, it changes from 7 to 12. And Y changes from 21 to 36.
21 to 36.
And then the delta X changes in chicken in pounds is 5.
5.
And then the change of chicken in dollars is 15.
Nailed it. Okay, and what do I do on the graph?
So you go to 7 again. You go to 721.
721.
And then you make a line, a horizontal line, going to the right
Well said. Okay, to the right on, yep.
And then it goes up to 36 on the y-axis.
And that delta x is our 5. And our delta y is 15. So when I asked what the graph represented, someone said like the relationship, right? And so yes, it's a bunch of points, but actually that's where we're going. These points all together reveal this relationship, and we see that relationship as we investigate how these quantities change together. And that's what we're doing all these, looking at the change of one and the corresponding change of another. That's about investigating how these quantities are changing together. So it's a dynamic situation, right? As we add chicken on the scale, the cost goes up. And we can quantify that, right? And that's what we're doing here. So we're trying to see this situation dynamically as these quantities are changing together. So the first day I said it wouldn't be wrong to say that this whole course is about quantities. Well, that's true. We can be more specific now. It also would not be wrong to say that this whole course is about learning how quantities change together. Learning how quantities change together. Okay? Here's two quantities. Total weight of chicken, cost of chicken. And so by doing all this, we're digging in and doing all this analysis, we're really starting to talk about how two quantities are changing together. All right, so let's look at that. We've got, actually, and I got another one. Could we say from, what do I got here, 12, did I erase it? Erased it, so we'll just say from 12 to 3. Is that valid? Can I say that x changes from 12 to 3? Is that valid in the real world? What would that be in the real world? What would that be like? You got 12 pounds of chicken on the scale, you take off how many? 9. So here I am with 12 pounds of chicken on the scale. And what happens first? Am I going to go down like this? No. The first thing that happens is, I'm going to take off. Best horizontal line I drew all day. Okay? No, just ruined it. All right. So I'm going to take off 9 pounds. So delta x equals 9? Negative 9. And that will be consistent with our final minus initial value of the quantity, right? Final minus initial will give us negative 9. Or this is a decrease, right? So a negative change means a decrease in the quantity. Okay? And then if we take 9 pounds off, what happens? Our cost is going to go down, right? It's going to go down how much? Oops. Negative 27. Yeah, so this should be what? 36 to 9. Negative 9. Maybe those are still there. Those are still there. So now let's focus on, when we look at these pairs of delta x and delta y, 2 and 6, 6 and 18, 5 and 15, negative 9 and negative 27. What's the kind of the arithmetic or the concept from your mathematical past that's showing up here? What is that about? 2 and 6, 6 and 18, 5 and 15. What's that about? Okay, so when you have one quantity that's always a multiple of another, those quantities are in proportion, right? This is about proportionality. What we have is proportionality of the changes. We have this proportionality of the changes. And when you did proportion problems back in junior high, how did you do proportion problems? What were those like? Fractions, right? Didn't you set fractions equal to each other? So in this first line, we could say 6 over 2, and that equals to what? 18 over 6 equal to 15 over 5 equal negative 27 over negative 9. And in all cases, we're saying we're taking what over what? In all cases there. Delta y, not y over x. Delta y over delta x. So remember, those quantities were changes in y, changes in x. So if we have proportionality of changes, then we have this constant ratio. In this case, the constant ratio of delta y to delta x. And what is the value of that constant ratio in this case? Always 3. And it goes back to our $3 a pound, right? $3 a pound. So when you have proportionality of the changes of two quantities, that the change of one quantity is always in proportion to the change in the other, this is what we call constant rate of change. This is how we get constant rate of change. Okay, it's not so. Again, proportionality of the changes in the quantities. Proportionality of the changes in quantities gives us a constant rate of change. And that constant rate of change equals the ratio of the change in one to the corresponding change in the other. So this is the value of the constant rate of change. So the phrase constant rate of change kind of has two meanings. It's the overall principle of what's going on, the idea that the changes are proportional, but then the constant rate of change is the number, right? It's the constant of proportionality. It's the number. So it's not only the principle that changes in the one quantity are proportional to change in the other, but it's the value of the constant rate of change. Okay, so there's more implications of this. So given that we have proportionality of the changes, this is kind of like the first fact. The first fact is that your changes are in this constant ratio, in this case 3. That's fact number 1. Fact number 2, let's erase real fast here. Fact number 2 has to do with if you knew what your change in pounds of chicken was, how could you always calculate your change in cost? So just think about that. Don't say anything. Just think about that. If you knew what your change in pounds was, how could you get the corresponding change in cost? So this is now we're talking about kind of perspective number 2. Perspective number 2 is, how could we get the change in cost given any change in pounds? What would you do? Back in the back. Multiply x by 3? Change in x, right? We're talking about the changes, right? So whatever your change in pounds was, we would multiply it by 3, the constant rate of change. So this perspective, so if that's always true, if the one changes in the one quantity are always a constant multiple of changes of the other, that's constant rate of change. So this is perspective number 2. It's called constant multiple reasoning. It's how you would find the change in one quantity given the change in the other. It's always a same multiple. In this case, it's always 3 times as much. So looking over here, 6 is always, if you have a change in weight of 2, you'll multiply by 3, you'll get 6. If you have a change of 5, you'll always multiply by 3, you get 15. What about negative 9, negative 27? Does it work? Yeah, it works. That's constant multiple reasoning. So that's perspective number 2 on this. Perspective number 1 is that our changes are in a constant ratio. Perspective number 2, the change in one quantity is always a constant multiple of the change in the other. All right, and then perspective number 3, I'm going to erase. Here's perspective number 3 on this. So I'm going to start with 0, and my change is going to be 3. When I increase the weight by 3 pounds, my cost goes up by how much? 9. I'm going to increase by 3 again. When I increase by 3 again, how much does my cost go up? 9 again. One more time. I'm going to increase by 3. Did I do that? It says, yeah, 6 to 9. I'm going to increase by 3. How much will the cost go up? 9. So perspective number 3 is that equal changes in one quantity result in what? Right, and so we don't want to use the word equal because the change in y wasn't equal to the change in x, right? But yeah, so when we have equal changes in the one quantity, we always get some consistent change of the other. So we'll use consistent to know that that change could be different, but they're the same, right? So every time I put 3 more pounds on the scale, I'm going to pay $9 more. So equal changes in one quantity result in a consistent change in the other. Okay, so to summarize, constant rate of change is about, it happens, you have constant rate of change when you have proportionality of the changes, and we have 3 ways of looking at that. The changes are in a constant ratio. The change in one quantity is always a constant multiple of the change in the other. And perspective number 3 is that when you take equal changes of one quantity, you're always going to get a consistent change in the other. So all of those 3 things mean or define constant rate of change between 2 changing quantities. Any questions? Okay, so web work's due Friday morning, and get ready for those in Friday recitation. You got your quiz.
Excuse me, Mr.
Yes, sir.
For yesterday, the web work, we had to keep these in our notes. Did we have to turn these
Yeah,
in?
no, you have to turn them in. It's just for your practice. Yeah.
Alright, just making sure.
Definitely do it. But it's just there's no way for you to turn in a graph on web work. But yeah, keep doing them.
I was a bit late. Did you take a 10?
I didn't take a test today.
Oh yeah, no problem.
You need it the rest of the day? If you do, it's okay.
I think I still have about half of my power.
Go ahead. I can go home and get mine.
Are you sure?
Huh? I need to get her cord back to her.
So I should be good for the rest of the day.
Professor Ashbrook.
Yes, sir.
Is this recorded or?
Yep, I
Okay.
record every session.
Okay,
Yeah.
thank you.
Which reminds me, turn it off.